Hi everyone, I'm Chitra Venkatesh. I'm here to talk about Agent2Agent protocol and the future of AI agent collaboration. I'll be talking about 5 topics. First, I'll talk about the challenges in today's agentic ecosystem. I'll then talk about how A2A addresses these challenges, the core features of A2A protocol, and how A2A protocol actually works. And then finally, I'll talk about A2A extensions and custom use cases and leave you all with resources. So let's get started. I'm going to start with a cookie cutter example of a travel agent or a trip planning solution. Let's say you're a developer and you're trying to build a trip planner. You would want to have, let's say, a hotel agent, a flight agent, an activity agent, and so forth. But typically, as developers, you don't want to be building each of these agents from scratch. Instead, you want to be able to leverage existing services out there, and these services may have tried and tested agents for some of these use cases. But as developers, instead of thinking about functionality of these different agents, you often find yourself asking questions like which frameworks these agents are built on, how are they hosted, how do you discover them dynamically at the time of orchestration, and so forth. And then if you're a provider of these agents, let's say you're a provider of a flight agent, you keep wondering, how are you going to broadcast information about your flight agent? How are you going to let other agents know that you have certain auth requirements? This is where Agent2Agent protocol comes into play. It's an open standard designed to enable secure communication between agents. A2A was initially built by Google. It was donated to Linux Foundation. Today, we have over 150 plus partners contributing to the protocol. So let's talk about the core features of the protocol. As discussed in the previous example, without A2A, you have all these agents. They're disparate. They are not able to collaborate, let alone discover each other dynamically. And with A2A, they are able to interoperate. The core features of the protocol are, number 1, secure collaboration. It's ensured via HTTPS. Next is task and state management. So think long-running operations, asynchronous operations. And then UX negotiation is another feature. So if you have 2 agents collaborating, you don't want agent A to keep sending invocations to agent B until it gets the output in the right format. You want to be able to negotiate the output format between like agent A and agent B happening dynamically. A2A supports UX negotiation. Lastly, you want to have your agents discover each other dynamically. Capability discovery is another feature of the core protocol. So let's review how the protocol actually works. For this, I'm going to take a simple example of agent A, which is the client agent, and then agent B, which is the server or remote agent. Agent B is responsible for talking to the end user and formulating responses. Agent B is the one that's actually completing the task. So agent B sends a request to agent A sends a request to agent B. Agent B gets the request done, and then agent A responds to the user. For this flow to happen, the first thing is, how will agent A discover that there is an agent B that can actually do this task? A2A protocol supports the concept of agent card. Agent card is almost like a digital business card. It's a standard JSON file that's available at a well-known URL of agent B's domain. It talks about agent B, it shares the endpoints of agent B, the description, the skills, the task that agent B can complete, if there are auth requirements, if it can support streaming. All this information is available via agent card. And as developers, you will have to write agent card for your agent if you want it to speak A2A. Once agent A has discovered agent B and it knows that agent B is the right agent for that specific task, how does agent A actually talk to agent B? A2A supports communication via HTTPS. Every turn in the conversation is represented as one message. And the message envelope is gRPC. We also support gRPC today. And the message contains a few key components, such as role, whether the invocation is from a user or an agent, and then parts is the actual content. It could be textual content, or it could be a file that's being sent across. So then agent A sends a request to agent B, and then once agent B is done processing, it responds via another message. But how does agent B actually process the request? This is where agent executor comes into play. This is a Python class that the developer will have to write for their agent. So the first piece that the developer has to write is the agent card, and the second is agent executor. Agent executor is sort of a linkage between the core A2A plumbing and the logic of your agent. Once you write this class, the protocol is protocol SDK is going to take care of all the transport layer and the communication. So once agent A sends a request to agent B starts processing the request. Now, if agent B needs more time to process the request, you cannot make agent A wait on just one HTTP request for some time. That's not efficient. So let's talk about task management in A2A. So as soon as agent A's request is received, agent B realizes it needs more time to process the request, so it's going to create a task object. This task object it contains two or a couple of items. The key items would be the task ID and the status, whether the processing is happening or whether the task has been completed. This is going to be contained in the status field. So once agent A sends a request, agent B sends the task ID, and then agent A can, at regular intervals, ask agent B about the status of the task using the task/get method. And once agent B is done with the task, it can provide the summary in task.artifacts. But then polling is inefficient. Sometimes you may want to support push notifications and streaming. We do support that in A2A. So in case of agent B here, once the task is completed, agent B can send a push update to agent A once the task is complete. And then if the response is really long, it can break it into chunks and then send the response to agent A via streaming. So if your agent supports push notifications and streaming, you'll have to set the headers to true, as you can see at the top, the first slide. So to summarize, if you want your agent to speak A2A, you need to write two things. One is the agent card. The second is the agent executor class. Now let's talk about A2A extensions and custom use cases. Extensions are a great way to layer on top of the core protocol and then build for custom use cases. There are a few types of extensions. The first one is data-only extensions. So let's say you want to publish or broadcast additional information in your agent card. Let's say you want to say that your agent is GDPR compliant. You might want to include that as a data-only extension. One interesting use case is the latency extension by Twilio. They broadcast information about latency of their agents on their agent card, and then at the time of dynamic orchestration, based on latency information, the right agent gets picked for that task. The second extension is profile extensions. So let's say you want to add additional structure or constraints on the request response flow, then you can use profile extensions. Let me give you an example. So in the example of messages, if you want to constrain the messages to follow only a specific format, you can specify that through profile extensions. The third type of extensions are method extensions. So if you want to support RPC methods beyond what's supported by the protocol today, you can use method extensions. And lastly, if you want to support additional states or transitions in task management, you could use state machine extensions. Let me give an example of a recent agent A2A extension, which is Agent Payments Protocol, AP2. I'll give an overview of what this entails. So recently, as agents started picking up, we noticed a lot of user journeys around payments. But our current payments ecosystem is not designed for autonomous agents, it's designed for humans. What I mean by that is, let's say if you want to assign liability or if you want to resolve disputes, you don't have the ecosystem supporting autonomous agents. And that's where agent payments protocol came into play. It was launched recently, perhaps a few weeks ago, with over 50 plus partners in the payments ecosystem, mainly issuers, networks, and PSPs. And the way it works is it allows verifiable credentials. It's an A2A extension, and the type of verifiable credentials it mandates is, one is cart mandate, the second is intent mandate, third is payment mandate. So these are tamper-proof, cryptographically signed certificates that you can pass along. To learn more about AP2, you can refer to the documentation and their GitHub repo. So that's all I had on agent-to-agent protocol. AP2 was an example of an A2A extension. If you want to learn more about agent-to-agent protocol, you can check out our documentation at a2a-protocol.org. And we have about 150 partners contributing. So if you're interested in contributing, do let us know. Yeah. Thank you so much.
All right, do we have any questions? Got to be questions on A2A. Can you project? Or do you want to talk into my?
The only question that I have is that the challenge I see is as soon as you cross ecosystems, you'll then get the challenge of security and data privacy.
Yes.
You can't really control which information agents exchange between themselves. So, for example, I maybe want the agent to book my hotel, but maybe I don't want another agent to share my whole travel history with the booking portal. Is there any work that you know, or you yourself involved in any work that tries to tackle this topic?
That's a great question. To reiterate what he just mentioned, he was asking about privacy and secure collaboration. So let's say if context needs to be shared from a hotel agent to a flight agent, how do you do that securely? Is there any known piece of work? Is that? I would say that most of the work that's happening, at least on Google side, is on the enterprise side of things, but we are getting closer to consumer side too. I guess a lot of it would revolve around verifiable credentials, and then we would also layer some type of trust signals that help agents rank the other agent or know that this agent is trustworthy. And right now, on the enterprise side, it's relatively easy to tackle because you can just look up the domain, and then there are a few sort of KY, know your customer, know your agent type of information. But for a truly consumer space, it's harder to solve, but we do have several distinguished engineers working on this problem statement. Oh, sorry. Yeah.
So if an agent is working with multiple agents at the same time, how does the protocol manage the state continuity or context between the agents? Is there any centralized place where the state and context is managed, or else?
To my knowledge, I don't think there's a centralized state, but every task will have its own task object. So if a task is taking more time, then it will continue to say task is in working state, and then if the other task has completed, you just get a push notification if that agent supports streaming, sorry, if the agent supports server-sent events. Are you asking for enterprise use cases for A2A or generally in the agentic ecosystem? On A2A side, we are seeing adoption mostly on like the core product. Let's say if ServiceNow wants to have agents, I don't know how ServiceNow works, but this is an engagement that's happening right now. If they want to publish agents, or they want their users or developers to build agents, they automatically have sort of native functionality to make sure that any agent that's deployed on their system speaks A2A. So the adoption we are seeing is more on the enterprisey side, wherein anytime I deploy an agent, it automatically is A2A compliant. And then overall in agentic ecosystem, the type of adoption we are seeing is literally across the board. It's in knowledge work. In financial, it's picking up as payment protocols are picking up. But I would say it's across the board. Yeah.
Oh, I think we're done. Okay, perfect. All right. Thanks.
Thank you so
Chitra.
much.